Hello everyone. Today I'll talk something about OFDM, which is short for orthogonal frequency division multiplexing. Let's first see what is OFDM. OFDM is a multi-carrier broadband modulation technique for transmitting large amount of digital data. It is using a large number of parallel narrowband subcarriers instead of single wideband carrier to transport information. Because of this, it is easy and efficient in dealing with multipath and is robust against the narrowband interference. But it has some disadvantages, such as it has high peak-to-average power ratio and it is sensitive to frequency offset and phase noise. I will talk about this in detail later. It is adopted for various standards such as DSL, 802.11a, DAB, DVB, etc. There are many applications of OFDM. In digital television, European and Australian standards are using OFDM technique. In various local area networks, Hyperline 2 is a various line standard using OFDM. It is also used in asymmetric digital subscriber loop, so the high-speed data could be transmitted along existing telephone lines. Why is OFDM so popular for broadband systems? Because most broadband systems are subject to multipath transmission. One of the conventional solutions is equalizer. But the higher the data rate is, the more complicated equalizer will be. OFDM is a simple way of dealing with multipath because it has relatively simple DSP algorithms. Now let's have a look at what multipath is. The figure can show us an intuitive understanding of it. Yes, multipath is where there are more than one transmission path between transmitter and receiver. Multipath interference is a phenomenon in the physics of waves, whereby a wave from a source travels to a director via two or more paths, and under the right condition, the two or more components interfere. Multipath interference is a common cause of ghosting in analog television broadcasts because received signal is the sum of many versions of transmitted signal with varying delay and attenuation. Intersymbol interference is the effect of multipath on received baseband signal. Equalizer is one of solutions to recover data correctly, but the structure of equalizer becomes complicated as data rate increases, and intersymbol interference gets worse as well. Okay, let's go back to OFDM with more detailed information. OFDM is a multi-carrier system using discrete Fourier transform or fast Fourier transform. It could transform signal into carriers. This figure shows the difference between single carrier system and multi-carrier systems. The blue one is the original signal. The black square and the red curve represent for carriers, different carriers. Signal is spaced into many small pieces. Each piece is carried by equally spaced carrier. Every individual subcarrier has sin x divided by x spectrum, which is like this. OFDM system available bandwidth is divided into many narrow bands. There are about 2,000 to 8,000 for digital television and about 48 for Hyperline 2 standard. Data is transmitted in parallel in OFDM systems. Then how does OFDM solve multipath problems? There are two key points in OFDM. First, data is transmitted in parallel because data is carried on orthogonal subcarriers. Orthogonality of carriers is important because it ensures the signal can be separated at receiver side even though they overlap together, which eliminates inter-carrier interference. Because of the use of orthogonality, there is a half overlap of every adjacent subchannels. Thus, nearly double the spectral efficiency than single carrier transmitted system. When a certain frequency of the transmission channel exists fitting, only the subcarrier in that frequency will get affected. Parallel transmitting ensures the low data rate per subcarrier, which could diminish the probability of having inter-symbol interference. Second, cyclic prefix. Cyclic prefix is the amount of uncertainty allowed for the receiver to capture the starting point of a symbol period, such that the result of FFT still has the correct information. As shown in the figure here, it's adding an n fraction of the symbol to its head. Typically, 25% of the cycle is taken from the end to the front. When the time period of cyclic prefix is longer than the maximum delay spread time, tau submax, all the multipath signal whose time delay is shorter than tau submax will be not extended to the next symbol. Thus, eliminate inter-symbol interference efficiently. Here, let's look at how OFDM system works. The original binary data is input into modulation mapping modules. There are many different kinds of modulation schemes, such as PSK and QAM. Serial signal is transmitted into parallel signal. Pillar insertion is used here to ensure phase noise correction and frequency offset correction at receiver end. IFFT is used here to transform signal from discrete frequency domain to discrete time domain. Here, cyclic prefix is inserted. Then the parallel signal is transmitted into serial signal. Digital to analog converter convert signal to analog signal. There are many different kinds of noise in channel, but the addictive white Gaussian noise is the typical noise in channel. At receiver side, inverse transforms are used corresponding to the transmitter side separately. This is the OFDM system simulation result. This shows original input signal and final received output signal. As we can see from the comparison graph, the original and received signal are overlapped, giving us an intuitional result that OFDM system transmits and recovers data with less bit error. This is a bit error rate of different signal-noise ratio using 16 QAM modulation scheme. Although OFDM technique has high immunity from interference, it has some disadvantages in implementation. First, it has high peak-to-average power ratio, PAPR. which the peak signal power is much greater than the average signal power. The reason cause high PAPR is that OFDM signal is a sum of many subcarriers, which are sinusoids. Large signal peaks occur in the transmitted signal when signals in many of the subchannels add in phase constructively. Such kind of large signal peaks may result in clipping of the voltage of the signal in the digital analog converter, and it may saturate the power amplifier. So it needs linear amplifiers with large dynamic range. But this reduces the power efficiency of radio frequency amplifier at the transmitter side. There are some solutions, such as coding to avoid the peaks, clipping the peaks, redistorting the signal, etc. Second, OFDM systems are sensitive to frequency errors. Every individual subcarrier has sin x divided by x spectrum, which has side lobes. This is due to leakage of DFT or FFT. Large side lobes will result in more sensitive to frequency offset and drift than single carrier systems. At this condition, the subcarriers are no longer orthogonal. Thus, OFDM systems have tight specification on local oscillators to produce more side lobe subcarriers. This is an example of using OFDM technique. Okay, let me show you something about the program code. The simulation is written in MATLAB. OFDM.m file is the main file. It is made of two parts, the transmitter and receiver. Transmitter is calling this function. Receiver is calling this function mainly. Here at the channel noise. In the end of the code, I'm calculating the bit error rate under different signal noise ratio. In the end, I plot it. The transmitter here is doing encode data convolutionally, interleaving data, binary to decimal conversion, modulation, pillar insertion, FFT, and adding cyclic extension. In receiver side, it's doing removing cyclic extension, FFT, pillar synchronization, demodulation, decimal to binary conversion, de-interleaving, and decoding data. Okay, now let me run the code and show you the plot. It will take some time. So this is the bit error rate under different signal noise ratio using 16-QAM modulation scheme. Okay, these are all about the OFDM. Thank you for watching.